Alright, let's look at the homework 16.5, problem number 9. Alright, so let's compute these expressions. Alright, so let's do that. Alright, so we have, this is going to be a divergence of R. Right? So divergence of R is simply x, y, z. So this is going to be partial of x with respect to x is 1, plus partial of y with respect to y is 1, partial of z with respect to z is 1. So this is going to be equal to 3. So that one's easy, 3. Right, let's double check. Right, let's type in 3. Right, then submit for testing. Alright, it came back and looks like we got part A correctly. Alright, so let's do part B. Alright, so part B, we want to find the divergence of R times R. Right? So remember R is simply, so this is just the magnitude of vector R, so it's going to be a square root of x squared plus y squared plus z squared, right? Which is same thing as x squared plus y squared plus z squared to the 1/2 power, right? So if you take the partial derivative of this guy with respect to, say, x, then you're going to get this. So 1/2 in front, same quantity here, so I'm just copying it down. Subtract 1 from the power, so it's negative 1/2. And then partial derivative inside with respect to x will be 2x. Right? So you can cancel 2 on the bottom and a 2 on top. And then what you get is going to be, you're going to end up getting this. So this is going to be x on top, right? And the negative, so it's going to be on the bottom. But here, you have x squared plus y squared plus z squared to the 1/2 power is simply r. So you end up getting this. Right? By the same way, we have partial of r with respect to x is so with respect to, say, y is going to be y over r, and the partial of r with respect to z is going to be z over r. Alright, so let's compute the divergence of, right, r times vector r. So which is going to be simply a divergence of this vector. It's going to be r times x, comma, r times y, comma, r times z. Right? So if you take the partial derivative, so partial derivative of this with respect to x, so since it's a product, I'm going to use the product rule. Alright, so it's going to be partial derivative of r with respect to x is x over r times x plus r times partial derivative of x is 1. Right? Partial of ry with respect to y would be, I'm going to use the product rule again. Partial r with respect to y would be y over r, right? Times y plus r times partial y with respect to y is 1 plus, same way, partial of r is with respect to z is z over r times z, right? Plus r times partial z with respect to z is 1. Right? So what you get is going to be, so you have x squared over r. I'm going to put all these together. So here, I took care of this guy. And then I'm going to take care of this guy first, next. So you have y squared over r. and then take care of that guy, which is going to be z squared, right? And plus, you have 1r and another r and another r, so there's going to be 3r, right? But here, you can see that when you have x squared plus y squared plus z squared is r squared, so we can cancel r here and 2 here, so it's going to be r plus 3r, so that's going to give us 4r, right? So answer is 4r, right? So let's type it in. Right, answer is 4r. Right, let's check the answer. Submit for testing. Alright, it came back and looks like we got part B correctly. Right, so let's do part C. Right, so part C is going to be, we want to find the this guy is really the same thing as the divergence of the gradient of r cubed, right? So let's find that, right? So this is going to be, right, divergence, oh actually, sorry, I put r cubed, forgot there. Right, divergence, so let's find the gradient. So gradient is going to be, right, so we're going to have to take the partial derivative of this with respect to x, so it's going to be 3r squared. Then partial of r with respect to x would be, remember that it's x over r, so it's going to be times x over r. Alright, then next one, partial with respect to y would be 3r squared y over r. And then with respect to z would be 3r squared z over r. Right? Then you can see that we can cancel r on top, r on the bottom, r on top, r on the bottom, r on top, r on the bottom. Right? So what you get is really divergence of, right? So you're going to have 3, I'm going to actually pull 3 outside. So you have rx, comma, ry, comma, rz, right? So this is going to be 3 times, right? So we're going to have, again, we have to take the derivative of this with respect to x. It's going to be x over r times x plus r times 1. So very similar to the first one. And y over r times y plus r times 1 plus partial of that would be z over r times z plus r times 1. Right? So this is going to be, right, again you have a 3 times, I guess we can just use regular parentheses, so I'm going to just replace that with the regular parentheses. So here, right, so you have, first we have 1 r, there's another r, there's another r, so there's going to be 3 r's, so 3r, right, plus, then you have r on the bottom, here we have x squared over r, y squared over r, and z squared over r. So you're going to get x squared plus y squared plus z squared over r, right? But remember that this is just going to be here. Oh, that's going to be r squared. So we can cancel r on the bottom, r on top. So you have a 3r plus r, so it's going to be 4r times 3. So this is going to be 12r. So this is 12r. 12r. Right, let's double check. So we got the 12r. Right, submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.